Okay, so for this next one, this is a question 11B. B is completely different from question 11A, so you don't need to have done 11A to do 11B. They're like completely different questions. Okay, so in this particular case, they're asking us to find A and B, and this is all they've given us. Now, I'll be honest, the way I've done it was just the first idea that came to my mind. I'm not convinced it's the fastest, maybe not even the most direct, but what ended up getting signaled for me was seeing this sine A, sine B. Every time I see something like that, I immediately think, the sum and difference. And the one that gives you sine A and sine B right next to each other is cos. Right, so if you've got, the sum and difference results for cos, that's what gives you sine A, sine B. So that was my immediate thought. We're going to need to use that result somehow. And then when I looked over here and I saw 3x and 7x, it's like, well, how can I use the sum and different results to get 3x and 7x? Lucy, just a bit more quieter, please. Just play just a bit quieter. How can we get 3x and 7x? Well, I end up using 5x and 2x. That's the way we can use the sum and difference results to get our 3x and 7x. So sort of using those two different clues together ended up sort of leading me into this method that I'm about to show you. All right, so what did I actually do? So I said, well, left-hand side is equal to this. And what I did was, using this 5 and 2 idea, so I can turn this into sum and difference results, I replaced 3x with 5x, take away 2x. And then over here, I replaced 7x with 5x plus 2x. And by doing this, I can now use that result, which I know will give me some sine A, sine B's, so to speak. All right, so we end up with cos 5x, cos 2x, plus sine 5x, sine 2x. Take away, now I'm on to the second one here. So we're taking away cos 5x, cos 2x, and then it should be a minus, but we're already minusing, so we're minusing a minus, so I'm going to put a plus here, sine 5x, sine 2x. Doing that, we've got some cancelling that happens here, and we end up with two lots of sine 5x, sine 2x, which, funnily enough, we want this, to ultimately look like our right-hand side, right? This right here, right? So this is meant to look like, hey, sine A, sine B. Well, what is A and B going to be? Very simply, A is 5x, and B was 2x. Or it could have been done the other way, I guess. A could be written as the 2x, and then in that case, B would be the 5x. Again, in multiplying order does not matter. So that's one way to solve the question 11B. Hopefully that made sense. Hopefully you can see why I ended up using the method I did. Ultimately, it kind of felt a little bit just like intuition at the time. There were a couple little signals, somewhat subtle, that were telling me, hey, maybe use these particular results. And then it's just a matter of, finding a way to use those results that you think are going to get you what you need. All right, anyway, so that's 11B. The next question that's been asked for is question 14. 14A is pretty easy. 14B is really long. And if you're not being super careful, very easy to make mistakes. As I discovered, I ended up having to do 14B twice to get answer, which I think is correct. So anyway, let's have a quick look at them now. So 14A, hopefully you've already, by the way, done these questions. If not, if you've seen this for the first time, quickly pause the video, read through the questions so you know what's going on. Shh, that goes too loud. All right. So in this first one, part A, where we're trying to show that K is equal to that. And the thing that we've been told is that after 20 minutes, that metal B has dropped down to 125 degrees. Okay, so in other words, when T is equal to 20, the temperature of metal B will be equal to 125. These are a set of values that we're going to sub into the temperature of metal B. So let's go ahead and do that. So letting T equal 20 and capital TB equal 125, that ultimately gives us the result 25 plus 150 e to the minus, okay, T is 20, right? So I've replaced T with 20 and I'm replacing this capital T with 125. Okay, so subbing in our values, we get this equation here. All we're doing is just solving this equation to find the value of K. That's all we have to do. I'm going to take the 25 across the other side, giving us 100. I'm going to divide the 150. So taking the 150 across the other side will end up giving us a 2 over 3, right? 100 over 150 simplifies. I'm going to need an extra page. So we had, what were we up to? E to the minus 20k is equal to 2 over 3. And we're just solving for the value of k, right? So I'm just going to log both sides. I'm using log to the base e, right? Remember, it's the natural log. It has the shorthand notation ln, they will cancel each other out over here, leaving us with a 20k. Remember that logs and exponentials are inverse relations, ultimately meaning they undo each other. And over here, well, we just got the ln 2 on 3. And so what's k going to be? All right, so now we just, take the minus 20, divide it across the other side. You end up with this. That's the value of k. Now, if we go back to what they actually ask us to find, bang, there it is there. It looks different to how I've got it. They don't have that negative out the front. And they appear to have a 3 over 2 instead of a 2 over 3. Some people would assume I've done it wrong, but it's not the case. They've just simplified it an extra step. So they've taken, remember with logs, right? Remembering log law number 3 from the Mathematics Advanced course, any number at the front can be brought into the log, it becomes a power. We're doing that with this negative. We're going to take that negative inside, where it will end up becoming a negative. And of course, they resolve that negative power, because something to the power of minus 1 ultimately gives you the reciprocal. And this is what they wanted as required. Okay, so that was part A. That's how we do it, right? They gave us a set of values. When T is equal to 20, the temperature will be 125. We subbed them into the equation, and then we just solved the equation, going through just like normal. And then once we got our correct answer, right here, everything was looking cool, but unfortunately, they were asking us to simplify it a little bit. And so we had, a little bit of simplifying to do to get the end result down there. Okay, so part A, not too bad. Part B, how many minutes after being removed from the ovens will the metals have the same temperature, right? Go back to read the question if you wanted. The metals came out at different temperatures. Otherwise, it would be the easiest thing. T would be 0 if they were pulled out of their respective ovens at the same temperature. But it's not the case. They were at different temperatures. They were brought out into their rooms. They're cooling down at different rates. Eventually, at some point, those the 2 bits of metal, the temperatures will become the same. We're trying to work out how long that will take. So in other words, we're trying to find the condition when the temperature of metal A will be equal to the temperature of metal B. Okay, so we had our equations. TA was an equation. It was C, that one right there. So 25 plus 250 e to the minus, I think it was 1 on 20 ln, was it 5 on 3 t? If I've made a mistake right here, I'm in for a world of hurt. I really should be double checking, but natural risk taking. Okay, and the formula for temperature B was this, minus 1 on 20 ln, is it 3 on 2? T. Okay, alright. So, there are two formulas, and we're just trying to find when these two are equal to each other. So, that of course implies 25 plus 250 e to the minus 1 on 20 ln 5 on 3 t. When is this equal to the other one? ln 3 on 2 t. Okay, so we're solving this equation here. Really put some extra emphasis on where the equals is, because it's a bit messy. Take away 25 from both sides, and the 250 and the 150 will simplify, dividing both by 50. Okay, so we end up with 5 e to the minus 1 on 20 log 5 on 3 t, which will be equal to 3 e to the minus 1 on 20 log 3 on 2 t. Okay, so again, we're just solving this equation to try and find the value of t, simplifying any way we can. The complication for me is the power of the exponentials, right? It's really messy. And if I could somehow get the exponential of the natural log, they'll undo each other, right? Simplifying very nicely. I want to get this situation, meaning I need to like maneuver all the other stuff up there with the log out of the way. And the way I'm going to do that is to move everything up the top, right? Remembering log law number 3, we've seen that already in this exam, where, you know, you've got some log. If you've got a number out the front, it can be brought in, you know, up as a power. I'm going to sort of use that manipulation to try and get rid of everything out of the way, so the exponentials and the logs will cancel each other, if that makes sense. Okay, so what am I going to... Okay, that t has been... Okay, so we have a minus t on 20 ln 5 on 3. And over here, we have a... I'm going to write a little bit bigger, because it's easy to be confused with what's going on. Okay, so I've just brought those t's across and multiplied them. Now I'm going to use that trick of log law number 3. This minus t over 20, I'm going to bring in to the log, but in order to do that, it'll come up as the power minus t over 20, and same for this side. Bring that minus t over 20 in, and we get that. All right, do I have another page? Yeah, I do. Okay, cool. All right, so we have up here 5. I'm just going to rewrite it, just so I don't make any mistakes when I go from one page to the next. This is a minus t on 20. And this side we had 3 e to the ln, so 3 over 2 minus t over 20. All right, the exponential of the logs will completely undo each other. This was the whole point. They cancel, just leaving us with this. Okay. Hey, now this is starting to look a lot nicer. I'd be tempted to get rid of these negative powers. Right? The reciprocal. That negative's gone. This negative is gone. And the next thing I'm going to do is I want to get rid of this over 20 part. So the way I'm going to do that is to take both sides to the power of 20. Right? And this is going to be really cool because by doing that, well, it's going to leave us with this 5 to the 20, which is a bit scary because that's a really large number. But, you know, when we look at this next part here, they cancel fantastically. Index law number 3, you times them together, you just get a t there. And over here, you're going to be left with 3 to the 20, which is not nice. But, hey, you know, just to bring that down to just normal t, worth it. At least I think so anyway. All right, so how are we going to solve this equation? Again, I'm just going to, maybe just move all the t's to the one side and all the numbers over to the other side. Maybe that's the easiest way. Let's have a go for it. So we have 3 over 5 all to the power of t. And we're going to divide this by 2 over 3 all to the t, right? I've taken this over to the other side. And over here, we're going to have 3 to the 20 all divided by 5 to the 20. Hopefully you can see what's happens there. Right, over here on the left-hand side, we're dividing fractions. Right, we learnt that. I don't know who your Year 7 maths teacher was. But they did you a good service. Nothing we can really do on the right-hand side at the moment. That's just some sort of random number. It's going to be a small number, actually. Despite the massive powers, 3 to the 20 divided by 5 is going to be a small number. Simplifying this over here a bit, but now we're Lucy, you're too loud, sorry. Simplifying this here, you end up with 3 to the t times 3 to the t, all over 5 to the t times 2 to the t. You know what, there's so many different, the way I've just done it, I've just extended it a little bit, but that's okay. Okay, so we end up with, over here, extra page. 9 all over 10 all to the power of t, right? And over here we have 3 to the 20 all over 5 to the 20. Now we're trying to find the value of t. Nice and simple. We're going to log both sides. I did log to the base e, but you could use log to the base 10, or you could use log to the base anything you wanted, really. Bring that t down the front. And so t will be the log of this all divided by the log of this. Type it in your calculator, press equals. They want it to the nearest minute. So if it ends up being, 15.7 or such. By the way, I don't have a scientific calculator on me at the moment, so I'm a little bit limited with the actual typing in of buttons into calculator. But type it in, round it to the nearest minute. If this ends up being a large number like, 252, right? You know how to convert this into hours and minutes, right? So go for it. If you do have any questions or if you need any parts of this explained in more detail, let me know and I'll do a separate video. But this is where I'm going to leave this video. There's 3 more questions that we need to answer, which I'm going to do in the final video. Alright, thanks. Hopefully this has helped, and I'll see you in the next one. So have a break if you need to, and then make sure you watch that 3rd video.